Hi, everyone. Welcome again to another IGS Global Seminar Series. This week, we've got another round of sea ice talks from Mark Serreze, who's going to be speaking on Arctic sea ice. Mark is, of course, from the NSIDC in Colorado. And we have Reid presenting on Antarctic sea ice, which I'm sure we've all heard in the news lately as it has recently fallen to a record minimum. And as Mark and Phil were just talking about, some weird things happening with Antarctic sea ice. So today we're going to get a nice view of sea ice in the Northern Hemisphere and the Southern Hemisphere. And yeah, with that, I will start streaming this and pass it over to Mark.
All right, well, thanks everyone. So yes, I'm talking about sea ice, but actually more than sea ice. It really involves the Arctic as a whole. And so that's why the title here. Why it all matters, evolving thoughts on the changing Arctic. And I say these are sort of my thoughts through, well, what's a fairly long career now in sort of Arctic climate studies. And just to start on this and why this won't advance theories, I first went to the Arctic back in 1982. So it was some time ago. That was with Reid, who was at UMass Amherst. That's just a picture of our little tent. And we were on top of these two little ice caps. I was looking at how these little ice caps were affecting the local climate, looking at differences in albedo, at differences in air temperature over them. And to kind of get at some of these ideas of like albedo feedback by doing some direct measurements of what was going on. And this was kind of inspired in part by the observation that there had been actually Arctic cooling going through some of the 60s and the 70s. There was even some talk, of course, about going into another ice age. But of course, at the same time, we already had initial modeling work coming out from, say, Suki Manabe and Jim Hansen that things were going to warm up. But, you know, most of us really weren't thinking about a warming Arctic at that time. And so there was that, you know, that idea, so we might be going into a cooling phase. But if you flash forward to about 1990, when the first IPCC came out, the first assessment report, there really wasn't much going on in the Arctic. And what I'm showing here is temperature trends up to that time, okay, up to about the early 1990s, what we were seeing. And we were seeing some areas of warming, like I'm showing there, some areas of cooling, just the sort of thing you'd expect from just plain old natural variability, no general warming, no Arctic amplification like we see today. You know, we later learned that a lot of this was related to the phase of the North Atlantic Oscillation, which then became popularized as something called the Arctic Oscillation, etc. But it really, a lot of it looked like just natural variability in terms of what was going on. Now, you know, I flash forward to a couple of years when I was doing some work out on the sea ice and the nearshore sea ice in the channels of the Canadian Arctic Archipelago with some crazy Canadian graduate students with a guy named Ellsworth Woodrew. And we were there in the spring of 1992 after Pinatubo blew. And, you know, Arctic warming was the last thing on our minds. We're working on things like multi-year sea ice. I learned how to make martinis out of good multi-year ice with its low salinity. And we had a paper published in 1993 where we were looking at sounding data from the Arctic. This is what it said. You know, we do not observe the large surface warming trends predicted by models. Indeed, we detect significant cooling over the Western Arctic Ocean during winter and autumn. This was from sounding data. So it was tropospheric stuff. So I wasn't thinking about climate warming. And in fact, at this time, I was a bit of a skeptic. You know, where's this warming we're supposed to see? Now, of course, the evidence grew that things were happening in the Arctic, notably in terms of the sea ice. Some of you may remember Drew Rothra, who was also at UW. He compared submarine sonar data collected between 1993 and 97, fairly recent at that time. Some of this had been recently declassified data with earlier submarine records. And this includes data from the first, of course, under ice submarine cruise, which was the Nautilus. And what he did was compared ice draft between at various places between this earlier data and the latest data, which I'm showing here on the left. And the more recent data showed this rather pronounced decline in ice draft. Of course, that's the part that's below the water. And of course, you can turn that into an ice thickness pretty easily if you adopt an appropriate density. So you were seeing things like, you know, a meter decline in thickness over like the North Pole region. So the point is that, you know, things were looking iffy, what's really going on, but then this evidence started to really emerge that things were really starting to change. And a lot of it came from some of this early oceanographic data that was coming out. So the evidence for change was growing, you know, but really, even by the year 2000, I was a fence sitter on this whole climate change thing, you know. It wasn't an issue that I didn't believe the physics behind it. It was a matter of what we were actually seeing. So I was on this paper with a number of co-authors, some you know, well-known names, everything from permafrost expert Jamie Morrison was on this course, and John Walsh, who I think a lot of us know. And this is what we said in the abstract, that, you know, taken together, these results paint a reasonably coherent picture of change, but their interpretation as signals of enhanced greenhouse warming are open to debate. That's what we said right in the abstract of that paper, right? But what happened, of course, is that eventually, and I would say by the year 2003, 2004, the evidence got just so clear at that point where I got off the fence and I said, okay, here we are. We are moving into a different Arctic now. It was just a matter of the evidence at that point, not trying to be a good scientist, of course. And where I think a lot of the community kind of really finally realized, my God, the Arctic is changing, was what happened in 2007, when we had what was at that time the record minimum sea ice extent. This blew away the previous record that was there in 2005. We, of course, knew the sea ice was declining through that time. The record was long to show that, but then along comes 2007, and wow. Now, we realized quickly that a lot of this had to do with an unusual pattern of weather, an unusual weather pattern that really got rid of a lot of ice. Just kind of an ideal pattern to get rid of ice. Nevertheless, you know, we started to realize maybe this is really something really, really changing in the Arctic now. So I remember scientists coming to our website every day looking at all the charts to see huge pieces of ice just being eaten away through the summer. So it really changed a lot of thinking, I think, 2007. Now, of course, there's a lot going on now. We know that trend has continued. We had a record low in 2012. Now, there's still questions out there. Here's our record low in 2012. We haven't gotten to that again, right? 2007, it blew away 2007. But people are realizing, for example, if you just look at the past decade or so, it's really one of variability instead of a downward trend. What's happening? Have we just gotten rid of enough of the thin ice now that we've just got the resilient stuff in there, and that's going to take a while to melt out? So maybe we just go down that trend line until we get to, what, 1 million square kilometers, at which point generally the thinking is that's what we'd say an ice-free end of summer. We shall see. So we know what's happening to the sea ice, but there are still puzzles out there. There's still a lot of stuff we don't really understand about what is happening. Of course, we have some of the same puzzles for the Antarctic sea ice, which we'll hear about later, but there's puzzles out there. Now, the thing is, what we're seeing in the ice cover, of course, is just kind of one example of these bigger changes that we're seeing all across the Arctic. Things like thawing permafrost. This is from around Fairbanks. I've been doing some permafrost work myself lately. You know, thawing and melting permafrost, massive changes of the landscape. We, of course, see a lot of Greenland ice sheet is losing mass. Just a picture of someone on a melt stream. It's probably a grad student, and hopefully, you know, we didn't lose that grad student. You never know. But yeah, the Greenland ice sheet losing mass. It's warming up. Of course, that's contributing to sea level rise. And I mentioned those two little ice caps that I worked on back in the early 1980s. They're dead. Here's this was from Aster imagery of what we saw in the summer of 2007, the big one and the little one, a couple of ice patches. They're gone. They're dead. Now, nothing left. And this was kind of something that made the issue of Arctic change almost very personal to me. I think about these ice caps are permanent things, and here we are, and those things are gone, right? Maybe I should go up there, put up a memorial. There is a cairn up there, I think, which has half a bottle of Jameson still in it. Maybe I can get that. But so I've really, some of my career or my interests have, I can say my research foci has changed a little bit away from just like monitoring things, understanding the physics, to looking at the impact. Things like rain on snow events, which I think we've heard a lot about, or people have heard a lot, how that interferes with ungulate grazing, things like that. I've been involved with that. Of course, there's, impacts of Greenland melting and sea level rise, coastal erosion, and of course, permafrost. All these impacts of Arctic change, the sea ice cover being just one piece of that. And of course, in the ocean, okay? So what's happening to the polar bears? As I think most of us know, it's a very complicated picture. Some population not doing well, some okay. What's happening to the walrus? Of course, they're an ice-dependent species as well, but there's a level of adaptability. They can haul out like on Point Lay and maybe manage. Things like phytoplankton blooms, if you see on the bottom right, more phytoplankton blooms, there's less ice, thinner ice, more life. But there's nutrient limitation that are going to affect what is going to happen. So it becomes a very, very complicated picture. So there's this physical side of things, of the change, and there's the issues of, the changes to the animals and things like that. But another issue which is central to the sea ice problem is Arctic change and geopolitics. Somehow I got drawn into this. I got drawn into this somehow, probably just because I've been in the business for a long time, and I've dealt with sea ice for a long time. And a lot of what we're seeing in the Arctic geopolitical arena, a lot of it really ultimately goes back to ice. Lots of tensions out there. So here you see a Tupolev 95 bomber, sort of the age equivalent of our B-52, still flying. And that's being intercepted by, I'm not sure if that's an F-35 or an F-22. Outwardly, they seem to look pretty similar. So I'm not sure. But yeah, lots of tension, right? The Arctic Council, which fosters cooperation, coordination, and interaction between Arctic states, right? Activity suspended, largely suspended because of the whole Ukraine situation. Really not much going on there. And of course, Russia needs to be an important partner in the Arctic Council. So this is just one example of how what goes on geopolitically in the world ends up being seen in the Arctic. And of course, Sweden and Finland joining NATO. I guess there's some pushback from Turkey. I forget it's with Finland or is it Sweden? I forget which one. But this is going to happen, and that's going to have. And these are both Arctic nations, of course, Sweden and Finland. So this is going to have ramifications. Militarization of the Arctic. These are not large bases, small garrisons, but there is this militarization going on in the Arctic. Issues of the Arctic high seas, new claims to the Arctic seafloor beyond the 200-mile nautical limit. Here's just a shot of one of these new air bases, the Nargoskoye, I probably have the pronunciation wrong, air base in Franz Josef Land. Look at that facility, nice, brand new, right? So that's what you're seeing up there in the Arctic. And if we think about what's going on in the US anyhow, the Department of the Air Force has this new Arctic strategy, right? The United States Navy regaining Arctic dominance. It wasn't clear to me they ever had Arctic dominance, but I guess they want to claim it. And of course, the Navy. And the title here is, I think, telling a blue Arctic, right? The issue here is an ice-diminished Arctic. And so, the Navy's saying, well, and I've talked to some of these Navy people, they say, well, I don't care why we're losing the sea ice. What I know is that now I'm getting to have a blue Arctic and I've got to deal with it. So this is what you're seeing. Now, a lot of this, some of this goes around oil and gas development. Of course, that is being made easier now because the sea ice is, because we're having less sea ice, especially in summer along this northern sea route area. These are just oil and natural gas leases that have been opened. Of course, Rosneft's a big player, Gazprom's a big player in that. But of course, Norway in the game. They've, of course, been producing in the North Sea, the Norwegian Sea. Of course, those are beyond the ice margin, but now in the Barents Sea, right? Going further and further north into some of the licensed areas. The U.S. as well. Now, of course, Prudhoe Bay production has been going down for a long time, but we are seeing offshore development in the Beaufort Sea. It's made easier by less ice. I think some of you have heard that the Willow Creek project was got the go-ahead. That's in the Petroleum Reserve to the west. But what will we see? What will we see going on? And the point is, less ice makes it easier to get out there and look for what might be underneath. Fisheries being impacted by the loss of ice. As I understand it, Russia has opened a new fishery for walleye pollock, Alaska pollock, in the Chukchi Sea. Because now with less ice, warmer waters, the fish are moving into the Chukchi Sea and now can be harvested. So we will see where that sort of thing goes. And again, it relates back to the ice. Then, of course, the whole northern sea route issue. Okay, so are we going to see the northern sea route be the new Suez Canal? And the answer is absolutely no. It's just not going to happen because for many, many reasons. Now, Russia, of course, has been operating on the northern sea route for a long, long, long time, but not much of it has been trans-Arctic. Right? It's been port to port to support oil, natural gas development, mining, like the Norilsk plant, things like that. Could things change? For example, if the Suez Canal got blocked, remember that Evergreen ship that got blocked some time ago, right? Terrorist threats, maybe that changes the equation. But maybe by 2050 or so, you see on the top left, these estimates of where the ice is going to be. You don't worry about going along the Russian coast. You take a ship right across. Maybe. But if you talk to experts on this, like Lawson Brigham and such like that, the idea of a new Suez Canal or Panama Canal, no. But we certainly are seeing more and more activity along there. Notably for things like LNG carriers. And these are specialized ships, so these are being built by South Korea. And the thing is, they're ice capable. And then this is the Christophe de Marguerite specialized LNG carrier. And they can take up to about 1 meter of ice, is my understanding. So, you can do a lot if you can take care of 1 meter of ice. And of course, the winter ice is getting thinner. Of course, Russia has an immense fleet of icebreakers, including big nuclear-powered ones, and they've built a number of new ones. Here's the new Arctica. The Sibir is another new one that I believe it's gone through its sea trials. But these are like 140-meter-long twin nuclear reactors. They can go through 3 meters of ice, something like that. So basically, operate along the northern sea route year-round. They're so capable. There are issues, as I mentioned, with the United Nations Convention on Law of the Sea on what's happening within the what are now the high seas of the Arctic beyond the EEZs of different countries. Russia has laid claim to new parts of the seafloor, claiming that the Lomonosov Ridge is an extended part of their continental shelf. It's in court. It'll probably take a long time, but it just goes to show you the things that are happening in the Arctic and how so much of it relates to what's happening to the sea ice cover. But as all this stuff is happening in the Arctic, of course, we know that the planet keeps on warming and the Arctic is leading the way. This is a figure of temperature change, 1970 to 2022. And I made it for November to April, cold season, because that's when you're seeing this Arctic amplification be so pronounced. We know that sea ice loss is a big driver of this Arctic amplification because now we have areas of open water we didn't have before, which now are releasing tremendous amounts of energy into the atmosphere in autumn and winter, even through areas of thin ice. And the the warming in the Arctic tends to be really strongly focused near the surface. So there is a strong, what we call lap rate feedback going on here, which really helps that Arctic amplification to kind of hang on there and be so strong. So again, it's sea ice that is so critical to this. So the sea ice issue in the Arctic, it's one of understanding the physics, what is going on. But so much of it is, what is it doing, right, to the animals that live there? But also it's very much involved in the whole changing geopolitical scene in the Arctic. So the planet keeps warming, we keep losing the sea ice, the Arctic is leading the way, but of course, we've only got one planet, so we should take care of it. So questions. Tried to go my 20 minutes.
Great. Thanks, Mark. Thanks for such a nice overview. We'll open it up to any questions.
Well, there's Magnus. Magnus, how are you?
Not so bad. Just became a grandfather.
Oh, good.
Seeley, was that a hand up there?
Yes. Mark, I wanted to ask you about the difference between polar amplification and Arctic amplification.
Yep.
Are we correct in using the term polar amplification? Because I don't see much down south.
No, we are not. We are not. It's Arctic amplification. Now, certainly that's what we see in the observation, right? That is Arctic amplification. There are parts of the Antarctic region that are warming strongly, like the peninsula, but it's Arctic amplification. And a lot of that, of course, has to do with just a completely different geography. An ocean surrounded by land, at sea level versus a high ice sheet surrounded by the ocean. And the thing is, if you look at the observations, it's clearly Arctic amplification. And if you look at the climate model projections, it's Arctic amplification. The Antarctic is kind of the sleeping elephant, maybe beginning to stir on sea ice, which we'll hear about very soon, but it is Arctic amplification. The use of the term polar amplification, which goes way back to Svante Arrhenius, back in like the 1890s. That's incorrect. It's the Arctic.
Thank you.
Yeah. Any other questions? Got a few minutes before we pass it over to Philip.
Nice to see Magnus, because I got COVID when I was in Iceland when I was there. Did you know that, Magnus? It was that big reception we had that did it.
You mean the one up by the tanks?
That's right, the one up there by the tanks. That was it.
Yeah, well,
I remember.
maybe I didn't get anything. Luckily.
Anyone else? We'll throw it out once more. No. All right. Well, thanks so much, Mark. That was a really, really nice overview of the changes happening in the north. And I'm sorry to see that your glaciers have disappeared.
It really made it personal to me. It really did. And we've been watching it, for a number of years. We have a paper on it, looking at how this changed. And by 2014, only like 5% of them had been left. And then the death knell was back in 2018. So it was, it just kind of took it personally. They weren't my ice cats. They belonged to the Canadian government, but I sort of thought of them as mine.
But something tangible, right? Something you walked
Exactly.
on, but is now gone. Yeah. Well, great. Thanks so much, Mark. And Philip, we'll pass it over to you. We'll switch poles and we'll go down south.
Thanks, Dave. Mark, that was fascinating. Really, really fascinating historical overview. I'm going to share my screen now. It might be a screen actually. Okay. So the title of this presentation is Variability, the Highs and Lows of Antarctic Sea Ice, or why are the low Antarctic sea ice extents a bit of a concern? And I list the important people there and I thank them for their discussions over the years. And basically what I'm doing is presenting much of their work in a less coherent manner than than they would themselves. So I apologise for any misrepresentations. Thanks to NSIDC, Mark, and others, Florence, for your making your data available. Any mistakes that I've made, I'll own up to. Okay, let's see. How do we move forward here? Oh, there we go. So when I volunteered to give this presentation, I had a picture in my mind of what I'd present. But then this wonderful article came out, and it presents some of the things that I'm going to mention today in a very succinct and wonderful way. And so I'll focus generally on some of the things in the background of this paper, and at the end we'll get to this paper and mention some of the things that Ted and Rob and others say. So everyone should be concerned. The Antarctic sea ice reaches its lowest levels ever recorded. So we've all come across this. This is from Turner and Camiso from 2017, and it's Antarctic sea ice from 1979 to I think roughly about 2012. We had a slight increase in sea ice extent, and then since then a rather dramatic decrease. And I guess this is as Mark was saying earlier, it's variability. So we're going to pull apart some of the idiosyncrasies associated with this variability. We'll start with Claire and Nicolo's wonderful sea ice extent analysis paper that was published in 2021. And Claire has a way of presenting data that's amazingly beautiful. Monthly ranking of sea ice extent from 1979 to 2020, and circled is the area of extreme variability that we're going to be discussing. And one of the parts I find really interesting is a rolling record-breaking months of Antarctic sea ice extent, and they also present the same data for the Arctic. It's a paper that's very well worth reading. So it's this bottom diagram that we're going to pull apart a little bit, and I'll just explain it in a little bit more detail. So these are, this is just a quick snapshot of the monthly mean net Antarctic sea ice extent values. We're going to use this to show an example of the data that they present. And this looks at the blue values are record-breaking high values of sea ice extent. It starts off in 1979 at say February at 3.08 million square kilometres. It gets broken. Similarly with record-breaking low values, we'll use October as an example. It gets broken in 1982 and then broken in 1984. And you can extend this out to the full gamut of satellite data from 1979 to 2023. At the top are record-breaking highs, and at the bottom are record-breaking low values. And one of the things that really stands out to me is that predominantly the record-breaking high values are dominated during the late advance and early retreat season, where the record-breaking low values are predominant during the late retreat and early advance season, with a little bit of spillover to other parts of the year. And I think this is really worth highlighting because it touches on some interesting aspects of this. So let's take a closer look at the seasonal differences. Sharon and others published a nice paper in 2012 looking at the correlation between retreat versus advance, and found that retreat in one year is highly correlated to advance in the following year, and that the correlations are strongest in the inner pack region and mostly poleward of 70 degrees north-south. And in my words, that is late retreat and early advance. Within the early sea ice retreat, there is an opportunity for increased solar ocean warming. So we're seeing here that there's something associated with sort of the late retreat period and the early advance period of low values. So let's take a closer look at some of these values. The record high values in February go back. There hasn't been a record-breaking February for a couple of decades, and hasn't been a record-breaking low value in April and May and September for quite a number of decades. So that's the 1980 set a sort of a benchmark for some of these records. So why are we seeing some of these records? And I'll mention this, the tropical connection and regional variability, because Ted touches on this in that Guardian article, that there is a tropical connection between the ENSO variability and Antarctic sea ice extent. And this is touched on by a number of papers, but that is regional variability. In general, it could be suggested that the net sea ice extent is ENSO invariant. These values here in red and blue are the El Nino and La Nina periods, El Nino being red and La Nina being blue. And we can see that there's not a really strong correlation between the net sea ice extent and ENSO values, but there is quite a distinct association between the regional variations and ENSO. So Ted mentions that in the presentation, so I just thought I'd present some of those findings there. Another interesting aspect is, thanks to Sharon and BAMS for letting me use this figure, is the Antarctic sea ice seasonality, and this is from the recently submitted State of the Climate report of 2022 sea ice advance, retreat duration and duration trend. And the question was asked whether duration is a record-breaking period. In other words, is there more red there in that figure C, than any other period? And I just these values are just amazing. Duration there and retreat, 100+ days of anomalous values, and that's associated with, well, generally there was an Edmondson Sea low for much of the year that was sort of transiting backwards and forwards across the sort of Bellingshausen Edmondson Sea region, bringing warm air into that region there. causing a very early sea ice retreat. So the question was asked whether duration was a record-breaking value, and yes, the net duration was a record-breaking year. So it's worth having a quick squiz at these values, because advance seems to dominate the record high duration, where retreat dominates the record low duration. And if you compare, if you plot these values on top of the standard deviation, this is 1979 to 2014 standard deviation, you can see that, indeed the increased variability is quite distinct. The positive net advance anomaly is associated, is far higher than the two standard deviations, whereas the net retreat anomaly is far lower. So those show that indeed this is quite some statistically significant variability. If you get bored someday, ask me about 1980. It's quite an interesting year. So why are the recent low events important? And Rob Massam and others, Ted and others published this really nice Nature paper in 2018 looking at ice shelf vulnerability. And within this paper, they included some interesting sea ice factors that reduced sea ice duration, extent and concentration, leading to increased ice shelf frontal exposure to open ocean at critical times. Can lead to, under certain circumstances, sudden disintegration of ice shelves. So low values during the summer period, particularly, or at any time of the year, can lead to ice shelf vulnerability. Alex Fraser and others are looking at fast ice, and fast ice is one of those barriers that protect that can protect ice shelves. And in 2022, it set a new record value of fast ice for March. And again, this is a loss of a potential protective barrier. We also published a paper on coastal exposure, which sort of quantifies the vulnerability of the Antarctic coastline. An example, this is an example of Antarctic Coastal Exposure Index, and its unit is degrees in longitude, and it's from the 1st of March 2017, which at the time of the publication was the lowest value recorded, and also the birth of my daughter Katie. And this is an example of the Antarctic coastal exposure length. If you plot these values, if you plot, this is an example of the Antarctic Coastal Exposure Index from 1979 to 2012. The grey values represent the maximum minimum values of 1979 to 2012. If we add in some blue values, which represent the low years during 2013 to 2023, then we add in, that's right, during that period, there was concern about operations getting into East Antarctica due to increased sea ice during the summer period of 2013 to 2015. And that resulted in a COMNAP, the Sea Ice Challenges Workshop, which was held here in Hobart. And then you add the red values, which represent the high years during 2013 to 2023, and we can see quite a remarkable difference between those low values and the high values. And indeed, this is increased coastal exposure during late 2022 and early 2023. So this leads to enhanced temporal and spatial vulnerability of Antarctica's coastline. And some recent work by Nathan, who's a PhD student at Adelaide University, is looking at sea ice-free corridors, which looks at individual ice shelves and their associated corridors. And this is sort of some cutting-edge sort of stuff that Nathan's working on, and hopefully he's going to publish his next paper soon. So getting back to this Guardian article, within the article, Ted mentions that since 2016, there has been a fairly steep downturn in sea ice, and especially with the back-to-back record-breaking years, as well as many months being at near record lows, it's causing the scientific community to wonder if there's a process related to global climate change. He said that while most recent records could be related partially to La Nina climate system that tends to deliver warm winds to the continent's peninsula, that doesn't explain the loss in other areas. So while there's some regional variability associated with La Nina, it doesn't take into account the net sea ice extent values. Matt England stated that we don't want to lose sea ice where there are these vulnerable ice shelves and behind them the ice sheets. And Rob Massam, it's not just the extent of the ice, but also the duration of the coverage. If the sea ice is removed, you expose floating ice margins to the waves, and that can flex them and increase the probability of those ice shelves calving. That then allows more grounded ice into the ocean. And I think we'll end there on those very succinct and accurate words from Rob. So thanks, Dave.
Great, thanks, Phil. Thanks so much. We'll open it up to questions from the audience. Please use the raise hand function or drop them into the chat and I can read them out. There we go. 1980. We've got some time here. So Phil, maybe you can elaborate on what happened in 1980 a little bit.
Okay. Yeah, 1980 was a really interesting year. And I wish I was prepared for some Hofmöller diagrams, which some people would be familiar with. If you do an objective analysis of all of the years, you can work out which are the sort of boring years and which are the most exciting years. And by far and away, 1980 is the most exciting year of Antarctic sea ice extent, at least by one particular objective measure, which I can drop into the Facebook or something. I can drop the Hofmöller in and show you. It just works. It also works out. Rob Massam was down in the Weddell Sea at that time, so I'm just wondering whether there's some coincidence or otherwise.
Sorry, Phil, were you trying to share the Hogmoller?
I won't share that Hogmoller here because it'll take me some time to find it. But I might drop it into the Facebook. I think this is being on Facebook. I might just drop a Hogmoller in there.
Okay.
It basically looks at the standard deviations of sea ice extent, temporally and spatially, and if you look at the standard deviation of 1980, it's a big standout.
Okay, interesting. Mark, you've got your hand up.
Yeah, of course the La Nina is dying, and we're moving towards an El Nino. And there's even some talk I've seen on that cesspool known as Twitter that we could even be going into a super El Nino. Okay, so what are your predictions based on this if we go to a super El Nino?
I just saw that Pat also, it's lovely to see your name there, Pat. Pat also asked this same question. Given the correct atmospheric response to El Nino, and it's not always necessarily the case, there's quite a distinct regional change in the sea ice extent. So asking me to predict what might happen for the net sea ice extent is going to be a bit of a push. I work for the Australian Bureau of Meteorology, therefore I'm very cautious regarding my outlooks. There will be a distinct regional change, is what I will say, and it will be very interesting to see what the outside of the areas where there is regional change. It'll be very interesting to see what happens. It's basically the Earth setting up an experiment for us, and a sad experiment to some degree. Yes.
Interesting, Pat. I guess that kind of answers your question as well. Yeah. Any other questions about Antarctic sea ice? Maybe from somebody who kind of just mostly focuses on the Arctic. Are we seeing, has freeze-up begun in Antarctica, or is it's still too early and we're expecting sort of a delay in freeze-up? Is that?
Well, we passed the minimum. We passed the minimum a little while ago. It was, of course, a record low.
Yeah.
No, we're past it, and yes, freeze-up has begun.
Okay. Interesting. And I see Rob is claiming that 1980 wasn't his fault. He wasn't there, so he's in the clear.
And by the way, the Arctic has passed its maximum, of course. So Arctic spring is coming, Antarctic autumn is coming.
Yeah. Mackenzie has a question there in the chat. Phil, can you see that?
I can, thanks, Dave. Yeah, are the ocean and atmosphere affecting Antarctic sea ice at different timescales? It sounds like the shorter term interannual variability may be linked mostly to the atmosphere. Yeah, basically. And I don't want to speak off the cuff as an expert, but yeah, basically the atmosphere will present some quite distinct changes, but you know, you look at we've had now probably 7 or 8 years of quite low sea ice extent, and some quite distinct changes in the atmosphere during that time. So yeah, that does get you around to thinking that the ocean may be playing a significant role. And I could speculate on that, but I won't, because there are other experts here that would give better explanations, I suspect. You know, the sea ice is vulnerable, I guess, to sort of changes in the mixed layer. So that's potentially one of the changes in the ocean that's worth looking at. But yeah, they're different timescales.
Yeah.
But there's feedbacks too. They're quite distinct feedbacks.
Yeah. Roger.
Yeah, thanks very much. Thanks to both speakers, but question particularly to Mark, and it's not really a technical one, I must admit, but perhaps for Mark and anyone closer to IPCC and things like that, it is something like an Arctic version of the Antarctic Treaty anywhere in reach, do you feel? I mean, that was quite a catalogue you listed of national reasons to be involved in the Arctic for national gain, and it seems a bit like it's a lost cause.
Mm-hmm. It's too late for the Arctic. Of course, the Antarctic's a much more recent player, in terms of science and things like that. What the Arctic has going for it is the Arctic Council. It's the council of the 8 Arctic nations that are there to try and promote sustainable development in the Arctic with respect of indigenous rights. That's what you've got is the Arctic Council. And it's been pretty effective in the past, as I understand it. But of course, you got a problem now with the whole Ukraine situation. So things are a bit in limbo, but that's what you've got.
Mm-hmm. Well, if nothing else, we can think positive, and I look forward to Svalbard Sauvignon Blanc in a few years, but that's not something I'd aspire to, but put up with. Thanks a lot for that overview. Appreciate it.
Well, I've got one final question since we bounced back to Mark. Mark, would you explain this? Would you describe this period since 2007, 2008? Would you use the word stable in Arctic sea ice? You mentioned the word variability, but it's not real stability.
Yeah, it's variable, but no clear downward trend. Now, of course, you don't want to say much about 10 years. It's a hiatus, I suppose. Okay, which is, of course, we're seeing the same sort of thing in the global temperature record. Now, I'm not saying the two are directly related, but you see these things in the climate records, and we've seen them before. We'll see them again. Why are we having this kind of you want to call it a pause, right? And it's debatable whether you want to call it that. I don't think we quite understand it. I would say. I think Walt Meyer may be on here. He may have another view on that. But I think what Walt has argued, I was talking to Walt yesterday, is that maybe we've gotten to the point where we just melt out the easy stuff now every summer, and what you've got left is the thicker, more resistant stuff, and so you're not going to see this, say, steepening downward trend that you might think. And here's Walt. Walt, what do you think?
Yeah, I mean, I think you got a point. I mean, it's, if you look at the trend from 2007 to now, they're the 16 years. It's the 16 lowest years in the record, but the trend is essentially zero. I was also going to mention that just today, it's gotten some press. There's a new paper, Sumata, that talks about a regime shift and kind of addressing this exact thing, where in 2005, 2007, there was a lot of loss of the multi-year ice. And really record low minimum, but since then it's been fairly stable, and they're seeing as ice is getting flushed out faster, it's not staying around as long, and so it's thinner and younger, but we're in somewhat of a stable zone at the moment. So it's kind of maybe shifted to a new quote unquote new normal, but for now at least it's kind of staying stable around that variability.
It is kind of arguing, though, that idea of a tipping point, where you're going to fall over an edge at some point when you get to some critical ice thickness. We're not seeing that.
Yeah, it's an interesting time because you see these wild swings. You highlighted 2012, but then you have 2013, and you have, I don't know, ups and downs. So it's an interesting paper, interesting period. The paper that Walt mentioned there just came out in Nature. I included a link there in the chat. It's a really interesting paper that, again, proposes a shift around 2007 from a thick from a thick kind of deformed ice cover to a much thinner, much faster drifting ice cover around 2007. So it's a good read. Okay, with that, I quickly wanted to plug on April 5th is the next sea ice round of talks, and we're going to switch away from all of this physics and remote sensing, and we're going to go to biology. We're going to go to under ice algae. So we have Carly Campbell from UIT in Norway and Stephanie Lim from Stanford, who's a PhD student there. They're going to be giving 2 talks on under ice algae in the Arctic Ocean. And I'm going to pass it over to Tavi, who is going to plug next week's talk. We've got a title shot coming up here.
Hi, yes, just to say next week we have 3 early career scientists speaking. Again, a Arctic and Antarctic mix, one from Greenland, one from the Antarctic and one from Canada. So just if you can come along and support the early career scientists giving short talks, that would be very much appreciated. So if you can come along, see you next week.
Absolutely.
David, can you send that PR slide to me, please?
Of course, yes, I will do that straight away.
Thank you. Thank you, Dave, for sending this one.
Yeah. So thanks so much, everyone. Again, this has all been recorded, so this will show up on the IGS YouTube page tomorrow. If there's anything you want to double check or listen or share with colleagues, it's a really good resource to kind of follow up on talks. I find myself going back and listening to some older talks every so often. So thanks so much, and we look forward to seeing everyone hopefully next week for the early career talks.
Live long and prosper. Bye-bye.
Here's to I prefer Cabernet Sauvignon, actually.